Now see gas laws. So let us discuss gas laws one by one. First one is the Boyle's law. See here, according to this law, when temperature of a given mass of gas is kept constant, its pressure varies inversely as the volume of the gas. That means PV is equal to constant. So P is inversely proportional to V if temperature remains constant. Now, the relation between P and V is shown here with the help of this graph. So here I have taken here these solid lines. These solid lines are representing PV curve for real gases. So all the solid lines like this for T3, this for T2 and this is for T1. So these solid lines are representing PV curve for real gases, and here all the dotted lines are representing here PV curve for ideal gases or the perfect gases. But now here you can see T1 is greater than T2 is greater than T3. So again from this graph it is clear that at high temperature and low pressure the behavior of ideal gases easily can be understood with the help of this graph. Now see the next one, that is the Charles law. According to this law, when pressure of a given mass of gas is kept constant, volume of gas varies directly as the temperature of the gas. That means V is proportional to T. Graphical study for the V and T. For this Charles law, you can see over here, there are the solid lines as well as dotted lines. So solid lines are representing for the real gases and dotted lines are representing for perfect gases, that is for ideal gases. Now see here, the third one is the Gay-Lussac's law. When volume of a certain mass of a gas constant, the pressure is directly proportional to temperature, that is P is proportional to T. So we have seen here PV is constant when temperature is constant, that is Boyle's law. Charles law we have seen V is proportional to T when pressure is constant, and third one is here when the volume is constant we have done P is proportional to T, that is called Gay-Lussac's law. Now the third one is also about the pressure. This is the Dalton's law of partial pressures. According to this law, total pressure exerted by a mixture of non-reactive gases is equal to the sum of the partial pressures which each would exert if it alone occupied the same volume at the given temperature. So P is equal to P1 plus P2 plus P3 plus dot dot dot. So this is the total pressure exerted by all non-reactive gases, mixture of all non-reactive gases here. So this is the Dalton's law of partial pressure.